we're going to learn about qualitative graphs. This is lesson 5.6. Here are your standards. You will be able to recognize a qualitative graph and interpret the scenario it represents, as well as create a qualitative graph. I think qualitative graphs are fun. They can be tricky. You just have to understand your relationship between the y and the x axes. So part of qualitative graphs is that it's not always going to be a numerical thing. A lot of times it's not a numerical thing. Generally, time is always going to be on your x-axis, and your y is going to be whatever the situation calls for. In this example here, it's percent downloaded. As you see, time is going on. So that's a big key. Time is continuous. But you guys should know that already, because time doesn't stop, as far as we know. I know, right? So if I look at this portion of the graph, if I look at from here to here of the graph, time is increasing. So for this interval here, time is increasing. As time is going on. As time is going on, the percent downloaded is increasing. Now here, time is still going on, but we've had a standstill with our percent downloaded. Okay, so it's not necessarily increasing at all, but it stays constant. Then after that section is over, we're now increasing our percent downloaded again. Time is still going on, increasing our download. Here we kind of flatline again, because when we're looking at a percent downloaded and over time, or y over x, this is a constant ratio, so a horizontal line with zero slope, right? So there's no slope here. There's zero slope here, zero slope here. Very important. Here, our slope is positive. So you have to know what positive slope is going up, is increasing, and then negative slope is obviously going down. Let's take a look at the next page. Well, here we go. Here's some of our examples of that. We have increasing at a constant rate, decreasing, right? I'm going up, it's positive, and this is negative, going down. Here, we don't have any change. Our m is 0. There's no change at all. This is at a varied rate. It's kind of going up. It's on a curve. Here, it's kind of going down on a curve. So if you look at this particular example right here, as I'm reading this here, this is our time, is our x-axis. This is our water level. Our water level is increasing as time is going on. At this point here, there's no change. Then maybe the water is, I filled up my tub here. Tub is now full, and the water's turned off, and now I am clean, and I'm going to empty the tub, and all the dirty bath water, boom, decreasing. Okay, so that's what that means. Take a look at the check right here. I want you to type your responses in the Edpuzzle. Okay, hopefully that's pausing for you. I'll put a big sticky there so I can know. Type responses in Edpuzzle. All right, at 3:20, 3:17. Now, we're going to sketch some qualitative graphs here. This might be kind of fun, might be kind of scary. Qualitative graphs represent essential elements in a situation in graphical form. That's what they do. They represent situations in graph form. We could sketch them, and it's going to look a little bit different, and that's okay. Your graph will look different than my graph, will look different to the person next to you. That's okay. They're going to be a little bit different depending on how they interpret their graphs. So let's go ahead and take a look at Charlie. Charlie's speed over time. Charlie is riding his bike. Okay, so you start off, I'm guessing he starts off at not riding his bike. So he's going to start off riding his bike. He speeds up, then rides at a constant rate, then slows down. It might look something like that. Okay. Go ahead and put yours in the Edpuzzle now. Put yours in the Edpuzzle now. At 4:19. Okay. Okay. Example 2, sketch the qualitative graphs. I want you to, all right. A tennis ball is dropped on the floor. Droppy, droppy, droppy. That's a tennis ball, right? It's dropped on the floor. On each successive bounce, it rebounds to a height less than its previous bounce. So it's going to go ba-boing, 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 ba-boing. Oh, is that what we're supposed to be doing? Well, I guess so. Okay. So it's dropped from, I didn't bounce it, it's dropped. So I got to change it, okay? Because we start from this height. This is the height that we started off at, and then we're going to go down here. If I had started throwing up this way, so I'm starting here, I'm going to go down here, so this is my starting point here. So I started here, so this might be, I don't know, 5 feet. All right, so ba-boing, 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 ba-boing. That's what it should look, something crazy like that. Oh, yep, there you go. Boom, there it is. Okay. Is the rate of change constant? Absolutely not. So it's non-linear. So it's because the rate of change is not constant, it's not going to be a linear graph. Okay. The graph is, I don't know what this is called. I don't know what they're looking for there. I don't know what their words are. I wish they gave us like a word bank to use, because I'm not really sure what they're looking for here. I wasn't really reading that. I'm not gonna lie to you, I don't always read that little tiny things there. What do they want us to say? Oh. Okay, well, it's going up. So this is increasing here, and down there it's decreasing. As it's going down, it's decreasing. As it's going up, it's increasing. Okay, but it's going to get shorter over time. All right, let's look at the next thing here. I can't read that. Okay, so this is what it says here, and you probably can't read it either because I have the same copy you do. All right, here we go. So this is what the words are. A person riding a bike slowly decreases their speed. They then quickly speed up. Finally, they maintain a constant speed for a period of time. So let's go ahead and draw that. I'm going to start it off here and go here. I'm going to go with time here for my x, speed here for my y. All right. I want you to do part A and part B on Edpuzzle. Okay. Okay, example 3, sketch qualitative graphs with values. Now we're going to have some numbers in here, okay? So Luis is walking to his friend Nathan's house. He increases his speed at a constant rate for 2 minutes until he reaches a speed of 6 miles per hour. It's a fast walk. He then decreases the speed at a constant rate for a minute until he reaches a speed of 2 miles per hour. Interesting. Finally, his speed increases at a varied rate for 3 minutes until he reaches at a speed of 8 miles per hour. Okay, so this is kind of a crazy way to graph it. So if you'll notice, we're going to go with at 2 minutes, that's the first thing. So you're going to plot the 2 minutes first. Then he decreases the speed at a constant rate. So he reaches a speed of 2 miles an hour. So I'm going down here. Here's my 2 miles an hour. Here's 2 miles an hour. That's my next one. So from here to here, that's a constant rate. So it's straight line. Straight line increasing, straight line decreasing. Finally, his speed increases at a varied rate for 3 minutes until he reaches a speed of 8 miles an hour. Here's the 8 miles an hour. I put my next point there. So the curve doesn't have to look exactly like that, but something along those lines. Okay. So I start off with he increases his speed at a constant rate from here to here. I'm starting off here, so it's at 0, 0, because I have to start up someplace. No time, no speed, not moving. Then I go for 2 minutes. So once I get that 2 minute block here, where am I at? He's going for 2 minutes until he reaches a speed of 6 miles an hour. So this is the first ordered pair, 2, 6. He then decreases his speed at a constant rate for a minute from 2 to 3. 2 to 3 is 1 minute until he reaches a speed of 2 miles an hour. So I go down here. So going down all the way down until I get to 2 miles an hour. All right. Now, after that, his speed is varied, so I could do whatever. I'm varying, but it's increasing until he gets up here at, because he's doing for 3 more minutes. 1, 2, 3, plus 1, plus 2, plus that puts me at 6 minutes here until 8 miles an hour. All right, now you do the check and put that in the Edpuzzle.